For the first part, we talked about the theory aspect of it, where we talked about what a support is, what is the different supports you have, what are the different supports in foundation, how can you determine which the foundation will behave as a as a pinned support or a fixed support. Okay, so we also talked about what are the things you can do if your foundation is behaving as a pinned support. What can you do to actually make it rigid or fixed? Okay, so we said we can include a grade beam. A grade beam is talking about your ground beam, that is your foundation beams. And also, you can use a plate beam as well to make your foundation become more rigid, become fixed. So, and then in that part one, I said in the part two of the discussion, I'm going to show us an example, and the aim of this example is to actually say or to show the importance of using plate beam on site because mostly these questions, why do we use plate beam? Is plate beam necessary in every foundation or every construction? So, and I said, let me make this video so that we all can understand the one of the things that the plate beam does. Okay, and this is the part I will be showing us the effect of plate beam on your building. So, from this now, you should be able to answer the question why it is necessary, when should it be provided. Okay, yeah. So, as you can see, this structure was designed without a plate beam. This was designed without a plate beam. Okay, and when we come to the column design, as you can see, we have our columns passed, passed, all columns passed. Okay, and you can as well look at the reinforcement required for this particular building according to the design. Okay, this these are the reinforcement. So I also like us to pay a close attention to this reinforcement, or you can actually screenshot it and keep it aside because we'll be comparing the results. All right. So just take note of this. So what we want to compare is when we model your foundation as a pinned support, what is the effect? We mentioned in part one that the effect of a pinned foundation, a pinned support, is because is you're going to have an increased moment in your superstructure. That means the lateral drift will be high. That also means that your column moment, the moment in the column, that is the bending moment in column and beams will also what increase. And when they increase, it will require more section and more reinforcement. So that's what we discussed in that part one. So now this is what we are going to see. This is what we are going to do now. As we have taken note of this reinforcement, this design was done with the assumption that the foundation is what fixed, that the foundation is a fixed support. That is the assumption here that the foundation is what is a fixed support. Then how do you know? Because on Pruta structure, automatically your support, the default settings for your support is what fixed. So then how do you know if the support is fixed or not? So I'm going to show us that. So what you're going to do is you come to view and view the analytical model. Okay, so when you view the analytical model, you come to this node here, as you can see, this node. When you click on it, then you click on the property. So when you click on the property, this comes up. So this property is based on this particular node at the foundation, this particular node. And you can see the node number. So as you can see, when you come to support conditions, this is the support conditions. You see that the X is restrained, the Y, the Z, they are what? Restrained. Then when you come to this is the lateral movement. The X is the X direction, the Y is the vertical, the Y is the, this is X is the, okay, is the horizontal, let me take it that way. Then the Y is the vertical part, okay, while the Z is, um, the Z is the upper movement. That is the movement uh, against gravity. All right, let me take it that way. So you see that this is the horizontal movement, this is the vertical movement. Z is against what? Gravity. Is the movement against gravity. Then likewise the rotation again for the X, for the vertical, for the Z. So you see that all of it is what? Restrained. So and this is what a fixed support does. Remember in part one we look at the different supports and we see that the simply supported and the roller support only um, only restrict movement in the what? Vertical direction. That is the Y direction. Sorry, in the Z direction. In the Z direction. That is for the simply supported and the roller. So then for the pin, we said all movement in the translational movement will also be what? Restricted or restrained, which is the XYZ. But the moments are allowed. The moments are what released for the pin support. But when you come to the fixed support, you see that the whole movement, both rotation and the translational motion, they are all what? Restrained. So from this now, you see that all movement is what? Restrained. This is a fixed support. Okay, for the bonus, you might be saying we model a pin support since the software comes with a default setting. Okay, so I'm not sure it's here, but let me get to the pin support. I will show us how we did that. Okay, so these are the foundation for this structure is done by what is fixed supported, and we are able to observe the the reinforcement. Okay, so now we have seen when this is fixed supported. So the next one is to see when it is what pin supported. What are the results that we have? Okay, so like I said, I will show you guys how to model a pin support. Okay, so in this and now we are going to see the result of modeling the foundation as a pin support. Then we see what the result you are going to have. You can now compare with the one of fixed support. So, so how we model as a pin support is by going to modeling. You come to support types. So when it comes to support types, this is what you see. This is from the default is from the router structure, the default setting. So, and you can see in our previous part one of this discussion, we listed the different types of support we have and the symbols for each of them. So I can see the one with a yellow color is the symbol of what? A fixed support. Then this is the symbol for what? Pin support. This is the symbol for what? For the roller support. Okay. So and when you click each of them, you can see that these are the movements that are being restrained. So the movements in the translation motions are what are now allowed or are being restrained, while as well the rotation are also being what restrained. So this is the behavior of a fixed support. But when you come to your pin support, you see that um, the translational motion is also what restrained, but you are now allowed to rotate. You are now allowed to rotate. Then when you come to ruler, you see that it's only the movement in the against gravity that is being what restrained. So and this is the support I've created, and you can see is the behavior of what a pin support. So, but if you want to create a support, you come to this, click on this plus button, then you are asked to name your support. I can name it as anything. Let's use G as the name of the support. Then you can now pick the support you want, and once you are done, that automatically becomes the the behavior of that support. So we picked roller, you can now say okay. So see that that support has been what created. Now, how do we now change the support of all these columns into that pin support? Because when I modeled, it was already with a default setting, which is what the fixed support. So since I've created a new support, how do I change it? So what I'm going to do is I'm coming to column. So like I said, I'll show you guys how to model a pin support. Okay, so and in this and now we are going to see the result of modern foundation as a pin support. Then we see what the result you are going to have. You can now compare with the one of fixed support. So, so how we model as a pin support is by going to modeling. You come to support types. So when you come to support types, this is what you see. This is from the default is from the router structure, the default setting. So, and you can see in our previous part one of this discussion, we listed the different types of support we have and the symbols for each of them. So I can see the one with a yellow color is the symbol of what a fixed support. Then this is the symbol for what pin support. This is the symbol for what for the roller support. Okay. So and when you click each of them, you can see that these are the movements that are being restrained. So the movements in the translation motions are what are now allowed or are being restrained, while as well the rotation are also being what restrained. So this is the behavior of a fixed support. But when you come to your pin support, you see that um, the translational motion is also what restrained, but we are now allowed to rotate. We are now allowed to rotate. Then when you come to ruler, you see that it's only the movement in the against gravity that is being what restrained. So and this is the support I've created, and you can see is the behavior of what a pin support. So, but if you want to create a support, you come to this, click on this plus button. Then you are asked to name your support. I can name it as anything. Let's use G as the name of the support. Then you can now pick the support you want, and once you are done, that automatically becomes the the behavior of that support. So we picked roller. You can now say okay. So see that that support has been what created. Now, how do we now change the support of all these columns into that pin support? Because when I modeled, it was already with a default setting, which is what the fixed support. So since I've created a new support, how do I change it? So what I'm going to do is I'm coming to column. So you come to story one, which is the ground floor level. That is the story one I've created. And you come to column table. So when you come to column table, so when you come to the column table, you come to support type. So as you can see, it was created with the default setting. So what we need to do now is to just change it to the one we have created. And for us to do that, you just click on the support type. And when you click on the support types, it selects all columns. Then you come to this icon that is looking like a book and a pen. So when you click on it, this comes up, and you can see the default setting and the support types we have created. So this is the ruler support we created, and this M is for the pinned support, which is of the main focus. So we select it, we click OK. So you see that it has been what uh, the support types have what has been changed. So now that we are done, we have set the support. So we now go on to carry out an building analysis. So the building analysis is done. Yeah. So after that, let's go on the column design. So we're going to compare the results. So where we see what we have, let's see what we have. Okay. So we check the steel, the previous steel we have. So we check the previous steel to see if actually it's going to work. If there will be additional steel or there is a need to increase some column sections. So let's just have the result and see what we have. So after the analysis, you see that when we have the fixed support, this actually passed with 4y16. Likewise, this one as well. All of them pass with 4y16. But since now we are now using a fixed support, you see that these columns are now what? Filling. Look at them. Okay, we have many of them here. See. So let's count the number. This is 1, 2, Okay, 4, 5, 6, 7. So you see that it was now 7 columns. I mean, yeah, 7 columns are actually filled. Okay, so we can now come to interactive design. Let's see what the problem is. That's what the problem is. Okay, so we can, the utilization ratio is more than 1, so we can increase the number of bars. So we have increased the bars from 4 to 6, and you can see the utilization ratio has reduced. So see that it has passed. Okay. From what we said in part one, we said when a model has a pin support, you're going to have increased moment in your columns, in beams, and the what lateral drift. So this is just an example of it. So now we have increased moment in 7 beams. And to use for us to solve uh, for us to solve these columns, we need to add the additional what 2 number of what reinforcement. So 2 by 7, we are going to have a total of 14 reinforcements added to the what 7 columns. So that is that. So as you can see, this is due to what pin support. But when we did our fixed support, this actually passed without any problem. Okay. So now what we are going to do again is we will now design using a pin support with split beam. Let's see what we have. So this is a pinned support with a plate beam. Plate beam. The fixed support with plate beam. So I've done the analysis and also I've done the design of the code. So just to show you the results. So let's see the results of what we have. So when after the result and the design of the column with that of the pins and the plate view. So we have that this actually required extra bar, that is 1 column. So we have the second one and we have the third one. Okay, so as you can see, we have 3 columns that actually filled and require extra reinforcement. But when we did only pin support, we have about 7 columns that require what? Extra rebar. So um, so we are able to see after the 3 cases, we are able to see that the plinth beam actually makes the foundation to be more rigid, and it will behave fully, partially as what a fixed support, not fully as a fixed support. Yeah. So it behaves partially as a fixed support and not fully a fixed support. So you can actually try your grade beam, that is your ground beam, and see what results you have. So it's just for you to play around it and see what you can discover. Okay, so this is just basically it. This is just basically it. Yeah. All right. So now you should be able to answer the questions. Why do we need HTML? Apart from controlling settlement, uneven settlement, you can also be used to make your foundation more rigid. So that is just the main uh, goal for this. All right, remember to to subscribe, like, and share. And if you have other opinions, please you can put down in the comment section. Thank you.